Okay, let's start. Today we are going to see the project proposal presentation. So this is the submission status. Most of you submitted the proposal presentation on time. So thank you very much for preparing and submitting this proposal. I really hope that you can learn from this project proposal or can benefit from this course project proposal. And there are some people who didn't submit the proposal presentation yet. So if you prepare, please submit as soon as possible. Okay, so the comment on this project proposal will be distributed within this week by email. And if you have some question or something to discuss, please come by my office. Okay, so today let's watch the presentation of the first 20 students in name order. Remaining student presentation will be uploaded in next week. Okay, let's see.
Hi, I'm Gang Kimo, first semester in the integrated course for the master's and doctorate. I'm majoring in the computer science and engineering, and I'm gonna introduce my project proposal, which is BioSQ transfer learning for the Boolean question answering of biomedical corpora. My motivation for the project is as follows. First, the recent success with pre-trained language models in various NLP fields. Versatile models achieved state-of-the-art performance on almost every NLP task. Second, NLP tasks in biomedical domain are still challenging, since the most of language models are pre-trained only on general corpora such as Wikipedia. Their performances are less superior than they used to be in general corpora. And further problems are described in here. And last, Boolean question answering has been mishandled in current researches, I think. Previous researches considered Boolean question answering task as one of the extractive QA. So their models are often fine-tuned only in extractive QA such as Squad, but according to Clark, it is more beneficial to fine-tune with multi-NLI than with QA tasks. Let me explain my problem formulation. BioSQ is the challenge for the information retrieval systems in the biomedical sector, and details are here. And I'm gonna solve only BioSQ, one of the subtests in BioSQ where the answer for a question is only either yes or no. And details are here again. I will show you an example of data set of BioSQ. This is single question answer pair in the data, and you can see question here and answer here and snippets. A sentence related to the question is here, and sources for these snippets is here. Okay, my related works are as follows. First, BERT is dominant state-of-the-art model in NLP fields, and BioBERT is a biodomain-specific language model pre-trained on large-scale biomedical corpora with almost same architecture with BERT, but it outperformed previous SOTA models, including BERT, in various bioNLP tests. And in BERQ, they built a reading comprehension dataset, BERQ, but additionally, they found that transferring from NLI data is more effective than from question answering data. So I will propose mainly two methods. First, I will fine-tune BioBird with multi-NRI dataset. And here is the explanation for MNRI dataset. And beyond the previous finding, attempts to change the model architecture or learning algorithm will be carried out. And second, the most QA models are trained only in single paragraph setting. So I will figure out this problem by using post processing. So I think about various normalization techniques, but it can be changed during experiments. And I expect these results. My method could achieve state-of-the-art performance in BioSQ challenge, and it would be analyzed why the model transferred from NLI dataset outperformed that from QA dataset. Thanks for listening.
Hello, my name is Kyungmin Kim, and I'm a student, integrated master's and PhD course. So let's start. My theme is a methodology of graph-based reasoning over heterogeneous external knowledge for general domain. The contents is as follows. Recently, I read a paper which is related to common sense and knowledge graph in question answering. In this research, they propose a method to automatically extract evidence from heterogeneous knowledge sources. Here, the key challenge is how to obtain evidence efficiently from external knowledge and make predictions based on the evidence. They use two graph-based module, word representation learning module and inference module. They generate evidence this concept net using the concept net and Wikipedia data. This is the heterogeneous data. They want to make model to select answer choice more exactly based on these evidences. This figure represents their approach. As you can see, they utilize these two data as heterogeneous data and use pre-trained model XLAD. It has a strong text understanding ability and has achieved state-of-the-art results on various NLP tasks. They also use other pre-trained models such as BERT Large, Robert A, and so on. But XLAD has best performance in this paper. Here I just wonder, this is the best way to extract knowledge, or this is the best way this is best pre-trained model for common sense QA test. So I want to study more efficient way, if it's possible, how to make more efficiently extract feature, or make the feature from external knowledge and general plain text. They use just concept net, so I think I can try any knowledge-based source such as WordNet, and they use graph-based algorithm. So I think it consumes too much memory. This is problem, but it is not easy. I'm not sure I can do this in this semester, but I want to re-implementation and try to apply other sources, even though they didn't release any their model or an source. This is related work. Common sense reasoning is a challenging research since it requires reasoning over external knowledge beside the inputs. Various downstream tasks have been released to address this problem, such as atomic, event to mind, MC script, swag. And Common Sense QA is a recently proposed dataset derived from ConceptNet. Lastly, as you know, there are some pre-trained models to adopt our research, such as BERT, XLAT, Robert A, and Albert. Yeah, this is my first presentation, and thank you for the listening.
This is term project proposal for 2020 Spring Pattern Recognition class. I am Seungryong Kim, who is in the 5th semester for integrated PhD course. My research interest lies in the financial data analysis, and my project for this class is also related to one of the main tasks in financial domain. My project title is Multi-Agent Reinforcement Learning-Based Portfolio Management System. As the title says, this project focuses on using multiple reinforcement learning agents to improve portfolio management performance. In this proposal, I will briefly introduce the motivation of using multi-agents in portfolio management and some related works. With the help of reference works, I will introduce how portfolio management problem is formulated in reinforcement learning and the goals of this project. Main motivation behind using multi-agent reinforcement learning in portfolio management is in diversification. There have been tons of strategies proposed claimed to be profitable, but no single strategy can make profit in every market condition. For instance, it is well known that momentum strategy performs well in bull market, but other strategies like mean reversion perform better in bear market. Therefore, to maximize risk-adjusted return, we need to have various strategies and allocate different weights for these strategies depending on the market condition. I was inspired by the fact that large trading firms like hedge funds have many investors with their own strategies but cooperate with others to maximize entire firm's profit. I think that by properly training multiple reinforcement learning agents, we can make entire systems like hedge funds. Each agent has its own strategy with its own belief about the market. However, they cooperate with each other to maximize profit of the entire system. Numerous works have been already proposed to improve performance of portfolio management with reinforcement learning. Although I wrote only 2 reference papers in my slide, as reinforcement learning is well known to possess nice property to be used in portfolio management, many researchers are interested in training reinforcement learning agent for stock trading. However, to the best of my knowledge, there is no work using multi-agent reinforcement learning to solve portfolio management. To solve any problem using reinforcement learning, we need to define it as Markov decision process. Definition here is how portfolio management problem is defined as Markov decision process in general. I refer to one of the reference paper I wrote in the previous slide. In Markov decision process, we have to first define tuples of state, action, and reward. In portfolio management, state is some features that can represent current condition of the market. Usually features from trading like price and trading volume are provided as state representation. Nowadays, many researchers include the position that the agents have as state information to prevent the agent to learn strategies with too much transactions. Actions are simply buy, hold, and sell usually, and reward are defined as the profit can be obtained by performing that action. Our agent will learn optimal policy, which is some kinds of rules dictating which action to choose at a certain state, and the decision is based on the value function, which might be action value or state value function depending on the design of the reinforcement learning. So my goal for this project is to generalize single agent reinforcement learning for portfolio management to multi-agent reinforcement learning. And my assumption is that training multiple agents could reduce profit volatility, resulting in high risk-adjusted return. To achieve this goal, I have to train each agent to be profitable itself, but at the same time, they have to act as differently as possible.
Hello, I'm Seung Kim from Data Mining and Information System Lab, advised by Professor Kang. Today, I'll introduce my new project about guided regularization method. First, I'll cover the motivation of the project, then problem formulation, and briefly explain studies related to regularization method. To train robust classifiers using deep neural networks, especially convolutional networks, several regularization techniques have been suggested to prevent coadaptation, which causes overfitting problems. Specifically, coadaptation means that some neurons are highly dependent on others as it inordinately focuses on a particular part of activations or on a specific area in input images. For example, dropout is a well-known regularization technique which drops hidden activations in random, and there is regional dropouts for convolutional networks which remove random regions on the inputs or on the feature maps. To avoid coadaptation, masking more focused hidden nodes or regions could lead to better generalization. From this point, dropping overly concentrated nodes or features would give more efficiency to avoid coadaptation, ultimately improves robustness. Dropout and regional dropouts employ random sampling for removing nodes or units. However, this kind of dropout cannot remove spatial correlation, and regional dropouts cannot promise to drop discriminative parts of the data. Therefore, regularization method adopting a semi-randomized procedure with a prior knowledge of important or discriminative subset would improve both performance and efficiency. There are a lot of regularization methods based on dropout, and there are fairly well-known ones here. First, dropout masks the random units in feature maps in convolutional networks. And there is spatial dropout, which drops several channels for each sample like this. And there is drop block. Drop block drops spatial continuous square units per channel for each sample, as illustrated in this figure. And lastly, there is drop path, which drops the whole layer instead of units, which is slightly different from previous ones. These drop units without the prior knowledge of units. In contrast, there are some dropout regarding which unit to mask. ChemDrop drops dependent units based on class activation map, like illustrated in this figure. And lastly, there is spectral dropout, which removes weak and noisy units via spectral transformation.
Hello, I'm Sonu Kim, working at Professor Seungjun Baek's lab, and this is my first semester of integrated course. I will talk about pattern recognition project proposal, analysis of emotional conditions through the barking of dogs. The motivation of this project is very simple. Nowadays, more and more people are raising dogs. I want to raise a dog if I can afford it later. People who raise dog want to communicate with their dog. However, it is hard to know how dogs feel. If people can see how a dog feels, they can communicate with their dog more easily. Dogs can express their feelings by barking or acting. So this is my idea. Just as a person's tone of voice changes depending on mood conditions, the dog also may have a different frequency of barking depending on his mood. Based on this idea, I want to analyze the feelings of dogs through barking sound using pattern recognition and machine learning techniques. Among Kaggle's dogs and cats crying data, I will use dogs crying data and make up for my lack of data through YouTube, where the data will be extracted 10-second WAV file format. Dogs may have complex and diverse emotions, but first of all, I want to distinguish the three most basic emotions: happy, sad, and angry. Since the crying sound data is not labeled by emotions, I can't use the user method of supervised learning to classify the data. So I will extract the feature of barking sound and group the data with the feature by using the clustering technique learned in class. I will convert the sound data to male spectrogram image data. Frequency component is one of the most characteristic factors of sound data, and male spectrogram is an image of sound data with time and frequency axis, converting it into a male scale to match human hearing. So by using male spectrogram image, it will be easier to identify the feature and cluster sound data. The result of searching about related work on Google, there was a project about classifying 10 different sound data in our daily life by using convolutional neural network and urban sound data made by New York University. This project also converts the sound data to mass spectrogram image to use CNN. This is my proposed method about my project. First of all, convert the sound data collected by Kaggle and YouTube to Bell spectrogram image, and initialize the hyperparameter about converting image, like frequency scale, time step, and so on. Then by using attention method, emphasize the most prominent feature of Bell spectrogram image. Unlike the related work, I only use the dog's barking data, so the distribution of Bell spectrogram image may be similar. This is why I use the attention, and then using K-means method, clustering the sound data. Through this process, it is expected that the sound of similar emotions will be grouped into same group. And this is my reference. Thank you for listening.
My name is Kim Woo-jin, and this is a project proposal presentation for pattern recognition class. For the project, I would like to study the task of solving data imbalance. A dataset is said to be imbalanced when the target class domain is skewed, meaning one or more classes are underrepresented in training data with respect to other classes. Imbalanced data is very common in real-world datasets, especially for domains like fraud detection, healthcare, and advertising. The figure here is data distribution of fraud detection dataset, and it exhibits low number of positive distribution compared to negative distribution. So the approaches for remedying imbalanced data in the form of data augmentation in computer vision domain have been extensively researched. However, the works on previous approaches other than data augmentation that combats numerical imbalance data has received little attention. Therefore, this motivates to study for approaches like data augmentation to handle imbalanced data in machine learning that targets numerical data. So the project for problem formulation is as follows. For this class project, I wish to examine existing traditional approaches that tackle data imbalance. I am hoping to implement those approaches to imbalance dataset and empirically evaluate and compare the effects of each approaches. If I have more time, I wish to further investigate the potential of these traditional approaches when they are applied to deep learning domains. For related work, I wish to evaluate each of those approaches in data level, algorithm level, and finally those that are hybrid approaches. For data level methods, I will implement random oversampling and smooth, as well as random undersampling with instance weighting method. For our algorithm level approaches, I wish to investigate ADA cost, which is misclassification cost sensitive boosting method. Finally, for hybrid approaches, I will examine the combination of sampling method and cost-sensitive method, which is smooth boost, as well as undersampling methods. And I will also, as well as smooth boost, I will examine ensemble approaches, which is creating an ensemble iteratively by applying random undersampling. I will implement these approaches in classification tasks and evaluate with AUROC metric and conclude the project with comparison of these approaches. So this is the end of my project proposal, and I have attached the reference at the end. Thank you.
Let me start presentation in pattern recognition's midterm project. My paper name is Stock Trading Analysis using Reinforcement Learning and Convolution Filter. So, first of all, let's talk about motivation in my paper. Nowadays, many machine learning algorithms have been developed and applied in many fields. But in stock market, which is characterized by a lot of noise and volatility compared to other fields, deep learning technology has not been applied much. So I was curious that will we be able to profit from stock investment using deep learning and reinforcement learning? Traditionally, modeling for stock price prediction was based on a time series model like ARIMA. And in case of deep learning algorithm, mainly RNN architecture is used. And in 2016, AlphaGo's advent of artificial intelligence using reinforcement learning could make machines outperform humans. So in investing in stock market, I want to try to apply deep learning CNN technology and reinforcement learning together. Here are the concepts of reinforcement learning. As same with other deep learning algorithm, there are objective function and loss function, and using stochastic gradient descent, optimize the parameters. But the difference between reinforcement learning and general deep learning algorithm is that in reinforcement learning, there are an agent and environment. So agent selects an action at a specific point in time. Reward is determined through the result and environment. This is the structure of my modeling that combines CNN and reinforcement learning. Lastly, referring to the following papers, I will research deep learning in the noisy stock market and stock investment using reinforcement learning, and CNN architecture. Thank you.
I'm Seungjin Park. I'm on the second semester for my master degree course, and now I'm studying in computer science department of Korea University. Today, I will present about visual dialogue task, which is one of the most challenging tasks in vision and language field. First, I will briefly explain the background and visual dialogue task. Visual dialogue task is an extension version of a VQA. For VQA task, the model should answer the question, which is visually grounded the given image, and the model should be able to answer only one single question. But visual dialogue task, the extension version of a VQA, consists of multi-round question answering pairs with an image. So the dialogue agent should answer a series of questions. Since the dialogue turns extend to 1 to 10, visual dialogue task is very challenging. So to address visual dialogue task, we should know what is the main problem for the task. First one is visual co-reference. It is different from reference resolution in NLP because the agent should consider not only texture information but also the given image. For example, when the agent meets question number 4, the agent should look up the previous dialogue history, and the agent capture question related dialogue history, something like question 2. But when you see question number 2, the sentence has a pronoun it, so the dialogue agent should solve what it refers to through the dialogue history and also the visual contents from the image. From this structure, the agent should capture the semantic intent of the current question and then should find out question-related dialogue history and visual contents from the image at the same time. The next problem is that the topics of question change as the dialogue turns going on. So the topic of question the topic of question 1 is asking about train, but question 3 is asking about train tracks. Furthermore, question 6 is asking about the buildings, which is the background of the image. So there has been various proposed methods for visual dialogue task. From 2018, more than 15 papers published about visual dialogue, and most of them are based on attention mechanism. So now I'm studying about encoder and decoder model based on attention mechanism. Specifically, there is no multi-view approach which uses both of word and sentence embedding. So my proposed network will use both sentence level, word level representations, and then to fuse texture information with visual features, the modality fusion module take the texture information from both word view and sentence view module, then combine them through 2 fusion steps based on attention mechanism. So yeah, thank you for watching my video.
Hello, I'm Mujin Sung. I'm in my third semester. The title of my course project is Using Deep Learning for Entity Normalization in Biomedical Domain. For the course project, the task I want to solve is entity normalization in the biomedical domain. Entity normalization is a task that maps a mention in a document into a unique ID. For instance, if the following sentence is given, a mentioned tumor can be mapped into the unique ID D009369. There are three challenges when doing the entity normalization task in the biomedical domain. The first challenge is when mentions with the same meanings can have different surface forms. We call it a synonym. The second challenge is when mentions with different meanings can have similar surface forms. The last challenge is that a dictionary is incomplete. It would be good if a dictionary covered all mentions. However, this is impossible in natural language. The problem formulation is that when a mention is given, we need to predict the unique ID of the mention from a dictionary. For doing so, the model should detect the most semantically similar synonym in a dictionary. The problem can be narrowed down to modeling synonym distribution given a mention. There were several studies which tried to tackle the biomedical normalization task. In 2015, the rule-based approach was introduced. They modify a mention using some heuristic rules and map it into a dictionary. The limitation of this work is that there are no perfect rules to cover all biomedical terms. In 2017 and 2019, the candidate re-ranking methods were introduced. They retrieve some candidates using simple search algorithms such as TF-IDF and re-rank them. The limitation of their words is that it makes the cascading errors. It means that if the first stage fails to retrieve any positive candidates, the next stage never makes the right prediction. So, I propose a method in two hands. In one hand is a single stage inference. The single stage inference uses a whole dictionary as a search space. So, it does not make the cascading errors. To do so, I will use the maximum inner product search strategy within all terms in a dictionary. The other hand is a two-stage training. Since training using the whole dictionary is infeasible due to hardware limitations, I will train the model using retrieved candidates. To improve the recall of candidates, the model should be trained to retrieve better candidates. Thank you for listening.
Hello, I'm Seungryong, majoring in Industrial Management Engineering.
I start the presentation about the supervised anomaly detection of high-dimension imbalance data with pre-trained AE using WGNGP. The table of contents is as follows. First, I'll tell you about the motivation. Let me explain about semiconductor manufacturing process. Due to the influence of the recent post-industrial revolution, the way of production in manufacturing is gradually being automated in digital way. Various sense data are generated in real time from these automated production systems. System failures in production system affect the entire process and result in economic losses to the business. Therefore, sophisticated anomaly detection technology for sense data is required. Let me explain the anomaly detection. Detect outliers means the classification of data for analysis purpose. Perform method including finding approximation of data. Sophisticated anomaly detection techniques are needed because anomaly can cause abnormal losses. But problem of anomaly detection. Because of the variety of sensors that process, there are many variables in the data which are likely to fall into the problem of cost of dimensionality. In addition, the imbalance problem from less anomaly data from normal data occurs. Let me briefly introduce to the related work class imbalance problem. The imbalance problem in a variety of real-world cases such as fraud detection, medical diagnosis, and semiconductor process. This means when the number of instances in moderate class is greater than the number of instances in minor class. A high imbalance ratio causes the classifier to create a classification model that is biased against the moderate class, thereby reducing the classification performance of the minor class. For example, if the moderate class has 99 instances and the minor class has 1 instance, classifying all instances into the moderate class, maximizing misclassification error within the confusion matrix of the minor class. So, generate artificial data from the minor class via oversampling, one of the data level method. Propose method. The flowchart for the proposed method is as follows. Step 1. Pre-train autoencoder. Step 2. WGAN GP oversampling. Step 3. Supervised anomaly detection in latent space. The main contribution is as follows. First, oversampling loss function, original GAN loss to WGAN GP loss. Enable stable learning. Improve computation speed by utilizing GP. More reliable calculation of anomaly score. Second, supervised learning using oversampling improves performance. I will explain about the experiment. First, the dataset is UEA and UCR time series classification repository semiconductor wafer data. 52 different sense set with 762 out of 7,164 total data. This study used data from 762 to 13 samples to mimic the actual semiconductor process situation. Initial results are as follows. Compared to raw data, we were able to confirm that good results came out when our proposed method used the random forest classifier. Further explanation and experimentation will be carried out later. Thank you for listening.
Bumjin An, and I'll start the presentation about my pattern recognition project. The project name is Localized Few-Shot Learning. Few-shot learning is a methodology that trains the model with only very few number of the data. Unlike the traditional data consuming deep learning algorithm, this few-shot learning is because this few-shot learning algorithm only use the very few data. In the real world, sometimes there is not enough data for the model training, So these areas are very important and rapidly growing. In particular, few-shot classification is a most famous task that the model gives k support image for each n classes, and the model determines which class is same one with a given query image. We are trying to develop a localization method that the model can focus on the important and some desired part of the image and apply it to existing few-shot classification model, and we want to make some performance improvements. Few-shot classification task is consist of some called episode, and each episode has k image for each n classes. Unlike the traditional classification problem, the class name of the image is not given to the model. For example, some traditional classification for the traditional classification task, the model knows that this image is the dog and this image is the class of the ship. This is the iPod. But in this few-shot learning task, the model cannot know about the specific class name of this image. So the only information about the image is which support image is same class with the query image. For example, this query image is same class with this image. So the only information that model can know is this answer B. Model is trained with some kind of this episode and validate with the novel classes to validate its generalized performance. Most popular model of this area is prototypical network. First, the network used the CNN network for feature embedding, and this model averages the k image features of each class and simply calculate the Euclidean distance of the query and support images. And simply it determines the answer class with which has the smallest distance. Another model is the Deep Nearest Neighbor Neural Network, also called DN4. This network also uses the CNN for the feature embedding, but unlike the prototypical network, it calculates the distance with each local feature instead of the whole feature embedding. This makes the network to focus on some important point to determine the class of image, but this network has weak point about that it can accidentally focus on the unimportant point, something like background. We want to use another network which output the degree of importance with the 0 and 1 value. Based on the DM4 model, we want to information from the important part of the image is more used, and the final similarity distance with the two images is determined through a weighted average using this importance degree. Thank you.
Hello, this is Seungryong. I'm recording to propose my term project subject. The title is Emotion Recognition in Conversation with Multimodality Processing. My major is computer science, especially natural language processing, also known as NLP. I dealt with text data set, but I'm not yet familiar with image and audio data sets. So through this project, I want to be more familiar with image and audio processing as well as text processing. So that's why I select treated the subject as multimodal emotion recognition in conversation. The problem is the multitask classification task. As you can see, we will take one sample dialogue, and there are speaker text as utterance and audio and video information. So and then we have to classify the proper emotion or sentiment. In NLP domain, the pre-trained language model is hot topic, and so I will use the pre-trained model, but I will deal with multimodality, so I will use cross-attention networks like Smart or Wilbert. Actually, my goal is not to propose any innovative work, but just to implement the multimodality processing. Okay, thank you.
Hello, my name is Won Yang. I'm interested in sound separation, so I chose this topic. Recently, noise-canceling technology, which removes noise from surrounding area, is applied and needed in everyday life. Especially, the technology is used in various fields, such as voice recognition technology, medical field, such as hearing aid, and voice device such as earphone and headset. This leads to sound separation technology, which refer to the technology to separate individual sound signal from mixed sound. This technology makes it possible to obtain desired sound information more accurately and to further improve noise cancelling technology by eliminating unwanted sound information. In the case of the existing sound separation consists of unit-based model, which have the disadvantage of effectively encoding semantic information because the deconvolutional layer are relatively shallow layer to create feature map by combining high resolution and low resolution during decoding. So I will present a way to overcome these shortcomings. It is also expected that sound separation performance will improve by overcoming shortcomings. There are three representative models of sound separation using machine learning. The unit structure is a single resolution structure and does not use feature. The dense unit structure is a single resolution structure and use feature to communicate all of model. State unit structure are multi-resolution structure that communicate within the same state. A number of noise separation studies have been conducted using machine learning, which use the encoder-decoder structure, much because sound separation technology requires sophisticated pixel-level segmentation. The problem is that the typical unit structure is a relatively shallow layer, so the problem is that the semantic information can't be encoded effectively, and information about the feature can be lost. This unit structure continued to link the feature map of the previous layer to the input of the next layer, solving the problem that the semantic information could not be encoded effectively. because of the relatively shallow layer of the existing unit structure. It also improved parameter efficiency by reusing feature map from previous layer. However, because that is a single resolution structure, there are problems with the multi-resolution structure and performing spatial information in comparison, and there are problems in memory management as well, because the previous feature maps are all saved and affected the next layer. Stacked unit structure is proposed to overcome the problem of single resolution structure by using multi-resolution structure, and it is a structure that enables more spatial information execution. However, the above structure has a disadvantage that the influence on the information may be small because it communicates only within the same state structure. That's all for the presentation. Thank you.
Hello, I'm Taeyeon Yang. Let me start the presentation of the project for pattern recognition. The subject of my project is just-in-time defect prediction. First of all, let me introduce defect prediction. Defect prediction is a technology that predicts potential bugs in a software project. We can do some useful things if we can predict bugs before testing. For example, we can determine the testing priority or use it as a reference when we review source code. In particular, just-in-time defect prediction is a prediction technique for common units. We can save more development cost if we can predict bugs before the code integration. However, there is no just-in-time defect prediction technology that can be practically used, so this study is necessary. Problem formulation. We will obtain information of changes from the source code repository and issue management system, and SZZ algorithm can identify bug introducing commit, so we can label buggy commits. Next, machine learning or deep learning approach will be applied to train prediction model, and trained model can predict the probability of bug proneness of new changes. Related studies are as follows. Yang et al. Provided an approach that learning with deep belief network using change-level software metrics as feature, but actually it didn't use semantic information of source code. Neuroless et al. Provided clever. It also uses change-level software metrics and adapt random forest algorithm as a training algorithm, but it also didn't use semantic information. Huang et al. Suggested a model named DeepJit. It learns source code and common message with convolutional neural network. This approach tried to extract semantic and structural information from the source code and common message, but it only used incomplete information because it uses changed codes and messages only. I propose a method that has not been used in previous studies. In order to utilize semantic information and structural information that were lacking in previous studies, I will extract abstract syntax tree from each version respectively, and the difference of these versions is used as a learning feature. Also, I'm going to try some methods that haven't been applied in this domain yet. For example, transformer or XGBoost and ensemble of these models will be tested. Finally, I will also test with a general and adaptive robust loss function that Professor introduced earlier. Thank you for watching.
Hi, I'm Dong-seok Go. The project I will develop in this course is word sense disambiguation with meaningful representation using symbolic graph. My presentation is as follows. In the section, I'm gonna talk about the word sense disambiguation task. The WSD is the process of identifying the sense of a polysemic word in knowledge. For example, the boy leaped from the bank into the cold water. The band pulled up outside the bank and 3 masked men got out. The first sentence bank leapt to the edge of river, and in the second of building. Next section is neural word sense disambiguation model. I will develop the word embedding using symbolic graph stable for the WSD model. And the WSD model to be applied with improved word embedding are shown below reference. This WSD model consists of 4 modules: context, gloss, memory, scoring. The first is context module. The context module encodes the local context of the target word into a discrete vector representation. The local context is a sequence of surrounding words. The context module uses LST module. The second is gloss module. The gloss is description of a word defined in a dictionary. The gloss module encodes all the glosses of the target word into a separate vector representation of the same size. Also, only expand the glosses of noun and verb via their corresponding hyponym and hyponym. The input for the LSTM is hyponym glosses, and the input back of the LSTM is hyponym glosses. The third is memory module. The memory module is employed to model the semantic relationship between the context embedding and gloss embedding produced by context module and gloss module respectively. Also, employ attention mechanisms to gloss module output and context module output. Finally, its scoring module. In order to benefit from both labeled context and gloss knowledge, the scoring module takes the context embedding from context module and the last step result from the memory module as input. Finally, it generates a probability distribution over all the possible sense of the target word. Next section is the conventional graph convolution neural net word embedding. The paper below suggests two Gaussian embedding, Shin-Gaussian, Sam-Gaussian. The first method is Shin-Gaussian, and the Shin-Gaussian utilizes dependency graph to learn more meaningful word representation. Extract its dependency graph using Stanford Core NLP parser from Wikidata. The second is word embedding using Sam-Gaussian. Sam-Gaussian is framework the semantic knowledge in learned word embeddings. So the inputs of Sam-Gaussian use synonym graph of WordNet PBDB. And the SEMGCM preserves the semantic encoded in pre-trained embedding by initializing SYNGCM embedding with given word representation and keeping target embeddings fixed during training. Next section is the proposed method with graph convolution neural network word embedding. I will add semantic role labeling graph to reflect the semantic relationship of words in the sentence. This meaningful representation is further enhances SEMGCM's performance. Next section is proposed neural word sense disambiguation model. The proposed model consists of 5 modules: context, clause, memory, scoring, GCN embedding. Thank you for listening to my presentation.
Hi, my name is Minhyung Yu. I study master degree of computer science and engineering in Korea University. My advisor is Professor Seungjun Baek. Today, I'm going to give presentation about one pixel labeled semantic segmentation. Okay, let's get started. As you can see in the title, my project is about semantic segmentation with few pixels. This is the extreme case of weakly supervised semantic segmentation. 2 datasets will be prepared. One is unlabeled image dataset. The other is pair of image and labeled mask, which has few pixel-wise label for each class. For example, if segmentation task has 5 semantic classes, 5 semantic objects and 5 pixels are needed. It can be spreaded into 5 images and 5 masks, or just into 1 image and 1 mask, which has every classes. By learning with the labeled few pair of data, unlabeled dataset will be labeled. So there are 2 tasks. One is classifying pixels, and the other is labeling pixels. Semi-supervised learning will be used for those tasks. Neural networks should learn how to classify pixel and give pseudo-label. One of the most well-known issues is labeling cost in semantic segmentation. For supervised learning, we should label every pixel. The cost increases in proportion to resolution and the number of images. If specific expert is required to label pixel, labeling cost goes much higher. And pixel is quite small to be classified, so it is easy to be classified incorrectly or classified by each person's intuition. Another way is unsupervised semantic segmentation. Neural network learn features and make segmentation by itself, but it may be different from humans' intent. So even 1 pixel of supervision is required to match humans' intent. And I think these problems can be solved with small and exact label. This task is regarded as a few-shot learning in the context of learning with extremely small data. Few-shot learning is one branch of meta-learning. In few-shot learning, neural network will be pre-trained with big data and fine-tuned on small data. But this task deals with few pixels, which is weaker information than few-shot. So I'm going to adopt with self-supervised learning to learn features of images, and given pseudo-label will be corrected repeatedly. So cyclic learning will be used. These are related works I searched. I brought 3 categories of paper. The first one is weakly supervised learning of instance segmentation with interpixel relation. There are a bunch of work in weakly supervised semantic segmentation. This got top rating of stars in paperswecode.com, which is famous deep learning state-of-the-art method browsing website. So I put this paper for instance. The second one is self-correction for human parsing. This paper gives simple method to correct wrong labels in segmentation task. The third category is about self-supervised learning. I introduced 2 recent papers for self-supervised learning. First paper used unlabeled dataset to outperform the given ImageNet classification task. And second paper used contrastive learning to learn representation of image without supervision. I'm going to use these main papers to solve given tasks. This is all for presentation. Thank you for watching.
Hi, my name is Yu, and I'm majoring in computer science. Today I will introduce about my project POS attributed learning using complex net LSTM. So let me explain about the motivation why I chose this topic. Firstly, I thought the feature reconstruction would be helpful to improve the performance of model, so I selected POS as the feature. And secondly, there have been some researches that models using complex number have an advantage on difficult tasks than real number modeling. But there are few NLP papers about that, so I want to try it on NLP task like language modeling. There were some problems to solve by implementation of my project. One of them is that data should be represented as complex numbers. There were some proceedings about audio and file and image file, but not for word embeddings. And secondly, there is a lack of long-term dependency in LSTM. It means words could not affect to another words in long range. So I'm gonna try to solve these problems. And related works. LSTM would be baseline model of my experiment. And the complex network, this paper would be helpful since I'm gonna build complex LSTM. And this paper also used complex recurrence network, but the main difference is that it only used audio data. So let me introduce about my proposed method. The purpose is that I'm gonna extract POS embedding from word embedding. So I set a specific function f by following this procedure. So firstly, I gather the words with same POS tags, and the only common part would be remained. Let me introduce by image. There are two words, and the circles means the units of word embeddings, and blue circle means large positive number, and red circle means negative number whose absolute value is large. And white circle means small number adjacent to 0. And I pass these two words to function f. And the function f is defined by this equation. Firstly, just element-wise multiplicate two words and pass the result to ReLU function. And finally, multiplicate sign of words who is resulted by this equation. Just element-wise divide the word value by its absolute value. So by this equation, only remaining part is that common part. So these two red circle is common, so red circle would be remained, and this blue circle is common, so blue circle would be remained. But this blue circle would be not remained since it has red circle. So the white circle would be deserted. So I got two embeddings. One is word embeddings, and the other is POS embeddings. So I will insert word embedding to real part and POS embedding to imaginary part. And finally, I get the complex value data of word embedding. And this data would be used to language modeling by complex LSTM. So the task would reconstruct not only word embedding, but also POS embedding. And I think it would be helpful to improve the performance. Thank you for listening.
Is Sanuri majoring computer science. My project title is Using Multimodal Features in Time Series Data about medical risk prediction. In the field of medical risk prediction, way of using patient visit data is a key point in disease progress prediction and survival prediction. LSTM has been used successfully in time series data in various fields, and time-aware LSTM, considering the difference in time between patient visit intervals is widely used in medical prediction field. However, the above model do not consider the relationship between different models in EHL data. EHL data is composed of various modalities such as prescribed drugs, surgery, disease. Also, the relationship between these modalities is very important for risk prediction. In medical risk prediction domain, it must be convincing whether the results of the model are reasonable for doctor decision making. The model being used only considers the visit interval, and it is difficult for the doctor to understand the relationship between the features. So the goal of project is to develop a recurrent model that can capture the relationship between multimodal features and improve performance. And hoping that such a model will give a doctor more reasonable, reliable result. Tests can take many forms. EMR data can be used to predict the patient survival, disease progression, and disease diagnosis. Survival prediction tests can classify whether a patient died within 6 months from the last visit, and regression, the risk bias index between patients. My goal is to find a way to effectively use multimodal features in time series data. This will be maintained until the end of the project, but the task to verify it can be changed within the project period. First, I will proceed to a task to predict whether a patient will die or live within 6 months from the patient's last visit. The input is the following X, and is the total number of patient visits to the hospital, and M is the number of modality types of data. Also, T is the total number of events that model can have in one visit. For example, you might think that patient X received a total number of T drugs at visit K. Why have 1 if patient died within 6 months from last visit? Otherwise 0. The goal is to predict whether or not to die within 6 months from the T visit if given data up to the PT visit. The call function can change and the call function can be changed and the task can be changed depending on the progress of the project. However, the input features will remain unchanged. As related works, time-aware LSTM retain, which is referred to as SOTA, for a long period of time in papers related to EHR data, and attain a combination of the two were referenced. Time-aware LSTM is a model that introduced the difference in patient visit intervals into LSTM. Attain as a time decay like a time-aware LSTM and add a attention weight to take into account the influence of each visit. However, this also only considered each visit, but the modal relationship was not considered. First, my proposed method idea, a simple idea, is to consider the time decay in LSTM and consider a method of offline self-attention or other types of attention to hidden units between modals. Thank you.
Good afternoon, Professor. My name is Sumin Lee, and I'd like to introduce my proposal for the course project in pattern recognition. I am currently majoring in natural language processing, so I also focused on text recognition also for the course project. So the title is here, the pattern recognition model for the KAIST Korean language reading materials, much well known as Suno.
Now to move on to the motivation, I decided to focus on course reading materials because, first of all, educational field in Korea has always been a blue ocean when it comes to deep learning. There were because relatively less attention on how to create contents useful for teaching by using machine learning. There are many reasons behind this, like, for example, there are figuratively no AI public data related to the education field, so there are no useful pre-processed data to be used. Also, when it comes to Korean educational field, whether it is a public sector or private sector, it is highly conservative when it comes to adapting new techniques or technologies. Secondly, when it comes to using text data in class reading materials, in familiar terms, 수능 독서지문 or 비문학지문, all the data exists in the PDF file formats for some reasons, and because also inside this PDF file, various 편집보스, whether I'm not sure whether it is an accurate term for this word, or editing signs such as over here a little bracket here on the side, or underlines with a sign here. It is highly closed or exclusive environment for the data mining because it is almost impossible to extract text patterns from including this editing signs from the PDF file format. For last, if, as I hope, recognizing text patterns from the class reading materials are done, it has a huge utility in the NLP field. To elaborate more, since every data in the class reading materials are only created in the PDF file format, and there are many types of editing signs and images including inside the PDF files, it is very difficult to extract text data by using traditional OCR techniques. To sum up, that is why establishing a text format for class reading materials with scalability, like to be able to be used in many research objectives related to the NLP, will be highly useful. Now to move on to the problem formulation, there are 3 goals for this project. The first one is to create pattern recognition to text data in PDF files and also including the images inside the PDF files of the 수능 독서지문. And secondly, to verify the meaning of these editing signs used in the class reading materials and create appropriate text that could represent the role of it within the text data. And for the last, to sum up, to create appropriate format for the class reading materials in text file format, which is a format that is mostly generally used for the data analysis, which means that it has a scalability. There were actually not much related words to this. Maybe it was due to my lack of ability, but I was able to find these 2 related words regarding the course project. First one is focusing on text sentence analysis of Korean textbooks. And of course, my goal is that to create a text format, not a text semantic or complexity analysis like this, but I believe there are still some details that could be utilized in this paper. So second one is a work on syntax recognition, which I hope will be useful to extract text data from image inside the reading materials. So this is the end of my proposal. It may lack some complex details because since it has only been a year and a half since I started to study this field, I actually used to major in law and Korean language and business in undergraduate studies. So this is kind of all new to me, but I will work hard, and thank you for listening, and I'm looking forward to hear your comments on this proposal. Thank you.
Hello, I'm Ingo Lee in the DMI's lab of the Professor Jae-gang, and I'm gonna present the course project of the pattern recognition class. My title is Spoiler Detection Using Graph Neural Networks. And let's begin. Spoilers on review websites, which reveal critical details of the original works, can ruin an appreciation for the works. As you can see in this slide, lots of reviews revealing main plot of the famous movie Avengers Infinity War had been spread widely, many users suffered from that spoilers. Review websites such as Rotten Tomato, IMDb, and Metacritic provide self-reporting systems that tag spoiler information to warn users of spoilers. However, since self-reporting systems depend solely on the active participation of reviewers, they cannot handle the fast-growing volume of newly generated reviews. As an attempt to solve this problem, several machine learning-based spoiler detection models have been proposed to solve the inefficiency of self-reporting systems. Nowadays, due to the success of attention mechanism, several attention-based approaches has been proposed recently. This slide shows the two sentences which contain the verb killing. The first sentence is a spoiler sentence because it reveals the scene having critical details of the original work. The second sentence is not a spoiler sentence because the phrase killing me is a metaphor using the verb killing with the word me as a direct object of the verb. However, the attention-based spoiler detection models would simply focus on the verb killing because killing is much more spoiler-like word than the others, and therefore classify both sentences as spoilers. This limitation of the attention-based models is due to a lack of using dependency relations between context words. Without considering dependency relations, the attention-based models are vulnerable to several spoiler-like words such as killing and ending. So, as problem formulation, each data point pair contains sentence S and label Y, and label Y is composed of 0 and 1, which mean non-spoiler and spoiler sentence. And sentence S composed of several words from W1 to Wn. Let G be the dependency parse tree, and V is the set of nodes of the G, and V contains n nodes corresponding to the n words in the sentence S. And E is the set of edges in G, which contains all pairs of adjacent nodes in the dependency parse tree G. As you can see in this slide, as example, W2 and W3, which meaning magicians and killed, are linked with the edge NSUBJ. That means the two words are in the relation of dependency nominal subject. As the result of my research, related words are here. So, with the success of GNNs, researchers have proposed the concept of syntax-aware GNNs that use dependency relations in dependency parse tree. The model figure in this slide shows the whole architecture of the model proposed in one paper. Referring to this idea of previous works, my goal of this project is to fully employ the information that dependency relations provide, which considers the relative importance of dependency relations that varies on the context of a given sentence, not simply rely on each individual words. I believe that this approach is more helpful in the spoiler detection area than existing attention-based models. Thank you.